In section 7.3, we're going to continue to solve equations by factoring. Remember the rules for solving equations by factoring. First, you have to have a factored equation that is set equal to 0, and then you can actually solve, and all of these equations need 2 answers. So when you look at number 1, you should notice that the equation is not set equal to 0. And unlike section 7.2, where the other side of the equal sign had a constant, this time we have a 3x on the other side of the equal sign. So we still need that one side to be 0. So if you think again of equation having 2 sides, we need to make the right-hand side 0. So if we subtract 3x from the right-hand side, we will have an equation that is equal to 0. But you have to do the same thing on both sides of the equal sign. So instead of subtracting 3x directly under the 40, I'm going to subtract 3x under the negative 10x because it is a like term with the negative 10x. So if I add up my columns, I get x squared. Negative 10 minus 3 is negative 13x plus 40 equals 0. So again, the only difference from 7.2 is sometimes the other side of the equal sign has something besides a constant. So make sure to line it under what it is like. All right, it's now time to factor. A times C is 1 times 40, or 40. Our B is negative 13. The sides of our x should be a negative 5 and a negative 8, because those are the 2 numbers that multiply to 40 but add to negative 13. Put those inside of your parentheses, so x minus 5 and x minus 8 equals 0. And now it's time to solve. Remember, you do not solve the equation until it is factored and set equal to 0. Now, these are the easy kind to solve because there's an invisible 1 in front of my variable. So we know that we can just say that first parenthesis would result in an x equals 5 as one of my answers. Think about why. If you put a 5 inside that first parenthesis, the whole parenthesis turns to 0. And in the second parenthesis, 8 minus 8 would be 0. So if that x were equal to 8, that second parenthesis would turn into 0. So your 2 answers are 5 and 8. All right, let's try it again. In problem number 2, if we break that problem down the equal sign, again, we can see that the right-hand side is not equal to 0. And this time, there are 2 terms that we need to get rid of. So we need to subtract 3k squared, and we need to add 8. We're going to make sure to do the same thing on the other side. We're going to subtract 3k squared right under the 4k squared. Line it up under what it's like. We're going to add 8 directly under the other constant. So you are making sure to make one side 0, and whatever you do to one side, you have to do to the other. Make sure to line up your like terms. Again, why did we do this? We did this because a positive 3 and a negative 3 makes 0, and a negative 8 and a positive 8 makes 0. So we're left with nothing on the right-hand side, which is why we get to write equals 0. Now, what have we done to the left-hand side? 4 minus 3 is 1. I'm going to make that 1 invisible, so I have a invisible 1k squared. I'm not doing anything to the minus 2k, so I'm going to leave that alone. And I put a positive 8 under the negative 43, which makes negative 35. I now have an equation that I can factor, so I make my x at this point. Negative 35 goes at the top, negative 2 goes at the bottom. My numbers that multiply to negative 35 and add to negative 2 are negative 7 and positive 5. I put those in parentheses with the k. K minus 7, k plus 5 equals 0. And now it's time to solve. For that first parenthesis, I'll get a k equals 7 because 7 minus 7 is 0. In my second parenthesis, I will get a negative 5 because negative 5 plus 5 is 0. So today is all about how do I make the right-hand side 0 before I actually can factor and solve the equation. All right, in number 3, we have to subtract 35 so that we can make the right-hand side 0. And what sometimes happens is there is no like term on the left-hand side. So where am I going to line it up? you really have two choices. Some people will put it up here at the top and put it as a minus 35 like that, which is fine. Some teachers don't like that. They don't like it up at the top, so they'll have you put it down here just kind of randomly in the middle. I think students make less mistakes if they put it up here at the top like this, because it's a constant and it belongs on the end, all right? So it's going to become k squared plus 2k minus 35 equals 0. So you can show the minus 35 on the left-hand side wherever you want, but make sure that you do not put it in the middle. Make sure you treat it like a constant and you put it on the end. So again, notice how I put that minus 35 on the end of the left-hand side because it's a constant. We always end our expressions with a constant. All right, now we can factor. We have negative 35 at the top. We have a positive 2 at the bottom. The numbers that multiply to negative 35 and add to 2 are 7 and negative 5. It looks a lot like problem number 2, but notice how the signs are different because the 2 is positive in number 3 and not negative like it was in number 2. All right, so we have k plus 7 and k minus 5 in our parenthesis equal to 0. Our two answers are therefore the opposite of what we're seeing because a negative 7 and a positive 7 make 0. So always picture that. If you would put that negative 7 in that first parenthesis, you would get 0. The second parenthesis will be k equals 5. And again, why is it k equals 5? Because if you would put that 5 in that second parenthesis, you would get 0. So that's why the answers are what they are. All right, the last three examples are the same type of thing. The right-hand side is not 0, so we have to force the right-hand side to be 0. Whatever we do to the right-hand side, we have to do to the left-hand side. And you should line up the like terms, unless like in number 3, there was really no place to line it up. That's why we kind of stuck it there at the top. But in number 4, there are places to line up our things that we're subtracting. So if you think about it, we have to subtract 1, so I'll line that up under the 17. We have to subtract m, I'll line that up under the 9m. Start adding up your columns. Remember, what you're really doing is subtracting 1m from 9m. So that becomes m squared plus 8m plus 16. And everything cancels off of the right-hand side. That's why we end up writing equals 0. We can now factor. We get a 16 at the top and 8 at the bottom. The numbers that multiply to 16 and add to 8 are 4 and 4. When we put those in parentheses, we get m plus 4 and another m plus 4 equals 0. Now this hasn't happened before where both answers are the same. Our first parenthesis, we get a negative 4, and our second parenthesis, we also get a negative 4. That's called a repeated answer, and you would learn more about what that actually means when you get into Algebra 2. So for now, you can either state it as a single negative 4 or you can write it twice. Either way would be fine with me. So if you ever get the parentheses are identical, you really only have one unique answer. All right, you have m equals negative 4. All right, in number 5, we have to subtract 7v from the right-hand side. So we will subtract 7v from the left-hand side. We do that so that the right-hand side becomes 0. On the left-hand side, what are we left with? 3v squared plus 20v plus 25 equals 0. We make our x. This time, don't forget that whenever you have something in front of your squared variable, you do a times c. It's not an invisible one. So 3 times 25 is 75. The bottom of the x is 27. The two numbers that multiply to 75 but add to 20, my bad. I'm sorry, I looked back up at the original problem. I shouldn't do that. I'm supposed to be looking right here at the start step. So we're going to put a 20 down there, not a 20, not a 27. All right, so back to our x. We would get a 5 and a 15. They would multiply to 75, but add to 20. We'll fill in our parentheses. V plus 5, V plus 15 equals 0. We will not solve this yet because it began with an invisible 3. I'm sorry, not an invisible 3, a regular 3. So don't forget, when you have a number other than your 1 in front of your squared variable, you have to divide, reduce, and move before you can actually solve. So we're going to divide by 3. That first fraction cannot be reduced, so we're going to move the 3 in front of the v. So 3v plus 5. The second parenthesis, 15 divided by 3, can be reduced. It's a positive 5 equals 0. Now that first parenthesis, we're going to set that equal to 0 because it isn't as easy as just saying negative 5 or a positive number will make that first parenthesis 0. We don't know what's going to make that first parenthesis 0. So we actually have to solve 3v plus 5 equals 0. Subtract 5 from both sides. 3v equals negative 5. Divide by 3. And one of my answers is negative 5/3. So if there's something besides a invisible 1 in front of your variable, you need to take the time to solve it. Now the second set of parentheses, v plus 5, that one I can solve just by looking at it. My v would be negative 5. Negative 5 and positive 5 makes 0. So sometimes the parenthesis needs a little bit of work and sometimes it doesn't. All right, last example, we are going to subtract 8x squared on both sides. And we are going to subtract 6x on both sides. The reason we do that is because the right-hand side is now 0, right? Positive 8, negative 8 makes 0. Positive 6 and negative 6 makes 0. So we now have our right-hand side equaling 0. Our left-hand side becomes 7x squared, 15 minus 8 is 7, plus 27x, 33 minus 6 is 27, minus 40. We can make our x. Number's going to get kind of big. 7 times negative 40 is negative 280. The bottom of the x is 27. This one would not be on your multiplication chart because remember your multiplication chart only goes up to 225. So the minute you get 280 up at the top, that's too big. So where do we look? We look at that 40. And we say this number is going to help us out. So the numbers that can make 40 are things like 2 and 20, 5 and 8, 4 and 10. And so I know what the answer is, so I'm just going to tell you, but those would be the numbers that you would try. So the answer is actually negative 8 and positive 35. So negative 8 and positive 35 will multiply to negative 280, but add to 27. So again, that can be a bit of a process. You might be trying things like 4, things like 10, before you actually get to the right combination. All right, so we end up with x minus 8 and x plus 35 equals 0. We do not try to solve it yet because we haven't finished factoring because that first term is a 7. Please do not go back up all the way to the top and say the first term's a 15. The first term is you're factoring at this starred step. So that's working, we're always working down. We never go back up to the top. All right, so we're dividing by 7. The first parenthesis, 8 over 7 cannot be reduced, so we move it, 7x minus 8. The second parenthesis can be divided, so we get x plus 5 equals 0. All right, the first parenthesis has a 7 in front, so we're actually going to take the time to solve that by setting it equal to 0, adding 8 to both sides. We get 7x equals 8, dividing by 7, and our one answer is x equals 8 over 7. The second parenthesis, the x plus 5 parenthesis, we're saying x equals negative 5. So if there's an invisible 1 in front of your x, they're a lot less work than when there's a number that's bigger than 1 in front of your x. All right, so very similar to what we've done in 7-1 and 7-2, but this time we have different kinds of expressions to subtract off of the right-hand side. Just make sure to line up those like terms and you should be good.